So just 5 and 6 then. Since those R and T mean nothing. Okay. I showed you guys how to do it before we left yesterday. Oh, you guys. Just when I thought period 3 your stock was rising. Okay, number 5. Okay, here's matrix A. 1, 1, 2, negative 1, 1, 1, negative 2, 3, 3. I even can look it up on the video. I know it's there. If this is matrix A, we're trying to find the inverse. Well, if I multiply any matrix by its inverse, what is the result going to be?
I.
1. No, it's I. Which is 1, 0, 0, 0, 1, 0, 0, 0, 1. And so we don't know what the inverse is, so what do we call it? A, B, C, D, E, F, G, H, I. Call this the ABC method. So don't forget the quizzes on Friday, yeah? PCH Quiz Friday. So if you multiply out the left one, didn't I do this yesterday? Who was here yesterday? I believe I did it. So if you go across and come down, you get A plus D plus 2G, B plus E plus 2H, C plus F plus 2I. Okay, then this one gonna be negative A plus D plus G, negative B plus E plus H, negative C plus F plus I, and then negative 2A plus 3D. So I have to do it twice for the camera. Negative 2B plus 3E plus 3H, negative 2C plus 3F plus 3I. That's got to equal 1, 0, 0, 0, 1, 0, 0, 0, 1. So this got to equal 1, this got to equal 0, 0, 0, 1, 0, 0, 0, 1, and then you solve those equations. Right now, that's the only way we know how to do it. It's too long. This takes like 1 minute. Okay, I'll do like one of them for you. Which one do you want me to do? The A, D, okay, I'll do the A, D, and G. So A plus D plus 2G. It's not like you're solving 9 equations, 9 variables. I mean, you are, but it's just 3 sets of 3 equations, 3 variables. Come on. Equals 0, and then this one gotta be 0 also. Okay, so to solve these 3, first you choose a variable to eliminate. Which variable do you want to eliminate? Well, see, the coefficients are all different, so it really doesn't matter. Pick one. Which one you want to eliminate?
A.
A. Wrong! No, okay, that's fine. Okay, so look at the first 2 equations. What can I do to eliminate A? Add them. So you get 2D plus 3G equal 1. Now you have to somehow involve the third equation. So how about multiply the first one by 2? So 2A plus 2D plus 4G equals 2. And then what do you do with these 2 equations if you want to eliminate A? You add them. So you get 5D plus 7G equal 2. Okay, now now we got it down to 2 equations, 2 variables. Let's see, this is algebra 2. Now we got algebra 1. So what do you want to do? Eliminate the G's or the D's? Pick one. Take a stand. He's guilty. Okay, D then. So multiply this equation by 5. Multiply this equation by 2. So you get 10D plus 15G. Why am I teaching you algebra now? 10D plus 14G equal 4. And if I want to eliminate D, U, it rhymes with subtract. Subtract. So G equal 1. Come on. And then once you figure out G equals 1, plug it back into one of these. Okay, this one. If I plug in 1 there, you get 2D equal negative 2, D equal negative 1. And once you get that, plug it into one of these. And probably this one's the easiest, right? So D is negative 1, and G is 1. be A equal 0. Yeah? And then you do the same thing for these three, then you do it again for those three. Right now, that's the only way we know how. You won't be able to do it. Anyway, this problem's on the test, I'll tell you right now. I'm going to give you a 3x3 matrix, you got to find the inverse. That's one of the 8 problems. You just got to do it. Now, you're probably not going to do it this way because I'm going to teach you something, but you can't do it. So right now, you have to do it this way. Don't do what some people did the last several years. You know what they do? They just wait. They don't do the homework. They don't do this problem. And then when we learn the new way, then they do it that way. You understand? You got to do it this way now. That's why it's on here. You guys got to build algebraic strength. Right now, some of you have got algebraic weakness. Okay, and then I'm not gonna do the rest. You guys do the rest. And then number 6. Say what? Okay, so I put this problem on just to see if you can read mathematical definitions, because when you guys go to college next year, or in 2 years, you got to read the book. I keep telling you guys, because in all probability, you're not going to understand your professor. If you even get a professor. You might get a teaching assistant, which is even worse. They can't speak English. Okay, 6a, problem 2. Here's matrix A. 2, 3, 5, 7. Okay, so what does this mean when you put a T over there? Capital T. A transpose, and that's important. The reason why I'm giving you this problem is because we're going to use it in the future. So how do you transpose a matrix? Well, what it says there, A transpose of ij equals A of ji. That means you just switch the subscripts. In other words, basically you're just switching the rows and the columns. So, I guess the fast way to do it then is, see how this is the first row? It now becomes the first column. The second row becomes the second column, and boom, you're done. Basically, you just reflect it over the main diagonal, because that's what happens when you switch the subscripts, right? Somebody going, what? Okay, what's the difference between A21 and A12? Where's A21? Isn't that here? Where's A12 that's here? So if you switch them, aren't they just reflecting over the main diagonal? And that's how you transpose a matrix. So problem 6b, you have to do the matrix in problem 5. So here's matrices. 1, 1, 2, negative 1, 1, 1, negative 2, 3, 3. So what is the transpose of this matrix? Well, the first row becomes the first column. The second row becomes the second column. The third row becomes the third column. See how it got reflected over the main diagonal? That's how you transpose a matrix. We'll be doing that on Friday, I believe. So probably Friday I'm going to teach you the technique of finding the inverse. Where you don't have to solve 9 equations, 9 variables. But then you have to compute 9 determinants. That's what we're going to do today. We're going to compute determinants. Okay, so today the fun starts. Now, at the very least, last year you guys learned how to compute 2x2 determinants, correct? You guys already told me you guys did Cramer's rule, and to do Cramer's rule, you got to compute determinants. So now you can't wiggle out of it. So how do you okay, so if you have a square matrix where the number of rows and columns are the same, we can compute the determinant of it. So let's start with a 2x2. Matrix A supposes A, B, C, D. Okay, so there's 2 ways you can write the determinant. One way is like this. That's called the determinant of matrix A. Or you can just use the straight bars, like this. I think that's the one you did last year, yeah? On your calculator, it's written like this, though. Okay, but they both mean the same thing, okay? It means A times B minus B times C. It's this times this minus that times that. That's how you compute the determinant of a 2x2 matrix. Now, it's very important to know the difference between a matrix and a determinant now. A matrix has the brackets. A determinant has the straight bars. And do not say absolute value because you're going to be laughed out of the dormitories if you do that. That's not absolute value, it's the determinant. So the determinant of a matrix basically just gives you a number, which is this times this minus that times that. So if you have this, what is that equal to? 2 times 7, which is 14, minus 3 times 5, which is 15, which is negative 1. It's a number. But see, the thing is, you can do lots of things with this number. It's amazing what you can do with this number. Like, well, you already saw last year, right? Kramer's rule. Okay, so 2 by 2, easy, right? A monkey could do that, right? Well, a smart monkey. Okay. But now, let's go to 3 by 3. How do you compute the determinant of a 3 by 3? You might want to look at your notes. So 2, 3, 5, make up something. 1, 2, 3, 3, 1, 4. Compute the determinant of this 3 by 3 matrix. See how I got the straight bars? Okay, now before we can compute the determinant, we need some definitions. First of all, how many elements are there in this determinant, in this matrix? There are 9. Each element has what we call a minor. Okay? So if I were to ask you, what is the minor? Okay, why don't we call this matrix A? So let's say matrix A is 2, 3, 5, 1, 2, 3, 3, 1, 4. Okay, that's matrix A. We're computing the determinant. What is the minor of A sub 1, 1? What the heck is a minor? Now, somebody told me in the other class that Mr. Takesu, you guys learned this, right? Or is it Mr. Rubash? Wait, Mr. Rubash. Did you guys do 3 by 3 determinants? So you guys know what a minor is then? What did you guys do then? Okay. Where's A11? Right there, okay? To compute the minor of this element, what you do is you cross out the row and the column that it's in. So if I cross out the row and the column that it's in, what's left? A 2 by 2 matrix, right? So the minor of that element is the determinant of that 2 by 2 matrix, which is 2 times 4 minus 3 times 1. 8 minus 3, 5. Every element has a minor. Okay? What would be the minor of A32? Where's 32? Third row, second column. It's right here, right? To find the minor of it, you cross out the row and the column that it's in, like that. And what's left? A 2 by 2. Compute the determinant of that. 2 times 3 minus 5 times 1. 1. There you go. And that's how you compute the minor. You guys get it? Now, does this look familiar, Mr. Ubashi's students? Crossing out the rows and the columns? Mr. Takeya's students have no clue yet. That's okay, I'm teaching you like you don't know anything. Okay, now we know what a minor is. What is a cofactor? What is the cofactor of A11? Well, it's the minor of A11 multiplied by negative 1 to the I plus j. Well, if you look in your notes, that's what it says a cofactor is, right? It's the minor multiplied by negative 1 to the I plus j. Now, what the heck is I plus j? That's the row and the column number. So, 1 plus 1. So, what is negative 1 to the second power? You really have to think about that. It's 1, and you multiply it by the minor of A11, which is 5. So, 5 times 1 is 5. What is the cofactor of A32? Well, it's going to be the minor of A32, which we already computed, which is 1. Then you got to multiply that by negative 1 to the 3 plus 2 power. What is negative 1 to an odd power? Negative 1 times 1 is negative 1. So what does a cofactor do? A cofactor is basically the minor multiplied by either 1 or negative 1, right? When you raise negative 1 to a power, it's either going to be 1 or negative 1, right? Okay, so let's just try one more. What is the cofactor of A23? Okay, what element is in the second row, third column? This one right here, right? Cross out the row and the column that it's in. What's the determinant of what's remaining? 2 times 1 minus 3 times 3. 2 minus 9. Negative 7. But then you got to multiply that by negative 1 to the 2 plus 3 power. 2 plus 3 adds up to 5. What is negative 1 to the 5 power? Negative 1. So the answer is 7. So a cofactor is simply the minor multiplied by 1 or negative 1. Now in your book last year, you might have noticed this printed in your book. You know what that's used for, this checkerboard? This tells you whether to multiply the minor by 1 or negative 1. Because think about it, like in this position, isn't the subscript 1, 1? So negative 1 to the 1 plus 1 is negative 1 to the 2, which is 1, right? Anytime you have a plus sign, you're multiplying by 1. If it's a minus, you're multiplying by negative 1. Can you see why?
Yeah.
Because in these positions, the I plus j adds up to an odd number, but in the plus positions, the I plus j's add up to an even number. Okay? Now this only goes for 3 by 3 now. If you have a 4 by 4, then you got to make the checkerboard like this. And it just expands, right, for as long as you need. But can you see that the upper left-hand corner will always be plus? Because 1, 1. 1 plus 1 is 2, which is even, right? Negative 1 to an even is plus. So all you got to do is remember the upper left-hand corner is plus, and then it just checkerboards after that. Okay, now we know what a cofactor is. Now we can compute a determinant. I think. Okay, so to compute the determinant of a 3 by 3, or actually this technique I'm teaching you works for 4 by 4, 5 by 5, n by n. Because some books they teach you. Did anybody read the book last year? Okay, so some books actually teach this. I'm pretty sure your book teaches this, you know. Okay, so you have this. You repeat the first column over here, then you repeat the second column over here, and then your book tells you to go. You multiply here. Don't do this because it only works for 3 by 3. So coming down this way, multiply these numbers. 2 times 2 times 4, 16. Then multiply these numbers. 3 times 3. Then multiply these numbers. 5, 1, 1. Minus, and then now you come this way. Multiply these numbers. 12. And then these numbers. 6. And then 30. And that's the determinant. But that's dumb because that only works for a 3 by 3. What happens when you get a 4 by 4? You try that same thing, it doesn't work. So it's dumb. Well, I guess it depends what level you're at, right? We're at the highest level. We're honors. We're not going to learn that baby way. Okay, so if you read your notes, to compute the determinant, you select any row or column. And this is the beauty of it. You can pick any row or column. I like to go across the top row, but it's up to you. Okay, go across the top row. Okay, what does it say? Multiply each element by its cofactor, and then add them up. Okay, so here's each element, 2. I'm going to multiply each element by its cofactor, like this, 5. And then you add them up. Okay, what's the cofactor of this one here? Cross off the row and column that it's in. You get 8 minus 3, which is 5. And do I multiply that by 1 or negative 1? 1. So it's positive 5. Okay, the next one here. If I cross out the row and column that it's in, you get 1 times 4 minus 3 times 3. 4 minus 9 is negative 5. But then you got to multiply that by negative 1 because that's in the negative position, right? So 5. See, that's always the hard part. You got to remember to multiply by the 1 or the negative 1. Okay, this element here, cross out the row and column that it's in. 1 minus 6 is negative 5 multiplied by 1. So negative 5. And then you simply add up these numbers. So that's what? 10 plus 15 minus 25, which is 0? I don't like the determinant to come out 0, but it just did. It's lucky. But see, this method I'm teaching you is good because you can pick any row or any column. It doesn't matter. Like what if you said, Mr. Park, I want to pick this column. I don't like the first row. Well, it doesn't matter. Pick the second column then. So you do the same thing. Multiply each element in that column by its cofactor. Okay, so here we go. What's the cofactor of this? 4 minus 9 is negative 5. Multiplied by negative 1, 5. Okay, this element, Cross out the row and column that it's in. 8 minus 15 is negative 7 multiplied by 1, so it's going to be negative 7. And then this element here, you cross out the row and column, you get 6 minus 5, which is 1, multiplied by negative 1, which is negative 1. And so you get 15 minus 14 minus 1. Hey, 0, it comes out the same. And that's the beauty of it. You can pick any row or any column. You guys don't seem excited about that. And again, this is just a technique. It can be perfected by just practice. That's why this chapter is so easy. Just practice is dominate. You don't practice, you undominate. Whatever that is. Okay, now, I taught this is the correct way, okay, but when the professionals do it, we don't. Watch what I do. I'm a professional. Pick any row or any column. Go, pick one, pick one. Top row. We already did the top row.
First column.
Okay, third column. Okay, do something different. Okay, watch what I do. Watch what I do. This is what I do. 5 times something minus 3 times something plus 4 times something. How come there's a minus on that one? Because that's a negative position. I put that negative 1 there already, so I don't have to worry about it. You know what I'm talking about? Because I'm telling you right now, the most common mistake when students do this is they forget that plus minus plus thing. So I put it in the beginning so I don't have to worry about it. And now you just got to do this. Woo! 1 minus 6, negative 5. 2. 2 minus 9, negative 7. And then, woo! 4 minus 3, 1. So you get negative 25 plus 21 plus 4, 0. That's how the professionals do it. Okay. Think you're good, yeah? So what if you had a problem like this? What if, and you are. Here's a determinant. Okay, let me just make up some numbers. 5, 6, 2, 1, 0, 0, 4, 3, 7. If you were smart, which row or column would you pick? Yeah, you pick the second row. Why? Because it's got 2 zeros there, right? And that's going to help you because if you go across the second row, what's going to happen? Is this the positive or negative position? It's going to be negative 1 times something plus 0 times something minus 0 times something. We don't care about those because you multiply by 0. So all you have to do is cross out the row and column that it's in. So you just get 42 minus 6, which is 36. So negative 36 is your answer. So the lesson to be learned is if you have zeros there, pick the row or column that has the most zero. Okay, now we know how to do a 3 by 3. Let's move on to 4 by 4. Now when you take your test, there's going to be a plethora of 4 by 4 determinants. A plethora. Okay, let's put in some numbers. 1, 2, 3, 3, 4. 2, 3, 5, 7. No, we're not going to put zeros. That's for weak people. 4, 2, 1, 3, 3, 1, 2, 4. I don't know, that 7 might make it too unbearable for you. Okay, now that method that I talked to you, the expansion by cofactors, that works for any size and square matrix now. So select any row or any column. Now tonight's homework, look, I gave you some 4 by 4, but there's zeros in them, right? So pick the row or column that has the most zeros. But this one doesn't have zeros as the part. Well, then we're going to have to do work. Pick any, yeah, that's another lesson. Why, you learned that already? When? Algebra 2? What about the rest of you? How come Kaiser High School can learn it, but Ilani doesn't? Anyway, pick any row or any column. I like to go across the first row. That's just me. So it's going to be 1 times something, minus 2 times something, plus 3 times something, minus 4 times something, right? Because plus, minus, right? I put the minus signs in there. Okay, so for the first one here, cross out the row or column. What's that? A 3 by 3. So you got to compute the determinant of the 3, 5, 7, 2, 1, 3. Oh, just wait till you do 5 by 5. Okay? Then 2, cross out the row or column. So what is that? I can't hold this. 2, 5, 7, 4, 1, 3, 3, 2, 4. Okay, and then the 3, this is going to be here now. 2, 3, 7, 4, 2, 3. See, if you're doing it on paper, you can just look at it or use pencil. Okay. So,
Can we use multiple pencils?
no. Yeah, you can do whatever you want.
I like the test.
Yeah. Don't worry, I'm going to teach you stuff. 2, 3, 5, 4, 2, 1, 3, 1, 2. Oh, so Mr. Park. So when I compute a 3 by 3 determinant, I got to compute 3 2 by 2 determinants, right? Yes. When you compute a 4 by 4, you got to compute 4 3 by 3 determinants. So imagine what happens when you compute a 5 by 5. You got to compute 5 4 by 4 determinants. Okay, here we go. Okay, so like I said, it just takes, it's not hard. Okay, how do you, so it's going to be 1 times, let's do minus 2 times something, plus 3 times something, minus 4 times something. Okay, we're going to break this class up. Okay, this one here, first row, do it now. Second row, third row, fourth and fifth row, go. And I'm going to raise all of you, go. Go. First, second, third, and then you guys do the last one. How hard is that? You guys are stalling for time. So did you get those numbers? I did 4. You guys could do 1, right? You have to do your 1. First row, did you get this number? Walk. You don't even have a pencil in your hand. Yoshina? I can do 4. You guys got to do 1? Okay, so what do we got? We got negative 10. No. This is wonder. 8 minus 75 plus 76. So that's good because that comes out to 1. So you just get negative 1. Oh, that comes out pretty nice. But how do you know I'm correct? I could just be throwing smoke. Or is it blowing smoke? How do we know that's the answer? Well, do you know your calculator can do matrices? Take out your calculator. Except on the test, you're not going to get to use your calculator. Or you might for one problem.
Will it work on Pocket? Oh no.
No, well, Pocket Cast, okay, if you got the free version, no can. No, wait. It can do one thing, that's why. I don't know. Maybe the Pocket Cast.
Matrices though,
Yeah. But the thing is, no, you're not going to get to use that on a quiz or test. Just take out your graphing calculator. Okay, now, if you have a TI, okay, let's call this matrix A, first of all. You know what the hardest part is? You got to punch in the numbers correctly. It's negative 1. Of course it's negative 1. I did it. No, I forgot what was the second. Okay, those of you with TI, this is what you do. You press the matrix button. You see the matrix button?
Yes.
Okay, then you press edit to input the numbers, edit, and then you can pick how many matrices do you have? A through what? Okay, whatever. Just do A. Okay, select A, which is 1. And then it says, what dimensions do you want it to be? 4 by 4. So you go 4, enter, 4, enter. And then boom, a 4 by 4 matrix comes out. Now you just input those numbers. So 1, enter 2, enter 3, enter 4, enter 2, and so forth until you get all 16 numbers in. Now those of you with a prism, who has the prism? Sang? Okay, press the, okay, well first of all, exit. How do you go to the mode? Okay, make sure you're in run matrix. Okay, then press execute. No, you had run matrix already. Run matrix, execute. Okay, then select matrix, MAT, which is F3. Okay, now it says matrix A, dimension, DIM, and we want it to be 4 by 4. So punch in 4, execute, execute. And then punch in the numbers. Now, the thing about punching in numbers, if you ever have to punch in a negative number, you gotta use the negative button. If you punch in the minus button, all hell's gonna break loose. Though. You gotta use the negative. Miyoka is not coming up. Timmy. Where do y'all? Yoshida? Is it coming up? Okay, are you in run matrix? What's that? Here, press. Okay, press menu. Okay, you are in run matrix already. Okay, press execute. Okay, press the matrix button. Add that. Okay, matrix A. Select it. Oh no, dimension. You gotta dimensionalize it. Make it 4 by 4. 4, enter, and then enter. And then input the numbers. Huh? You wait. Just punch in the numbers first, and nobody will get hurt. Okay, let's wait till everybody get the numbers punched in. Now you have to tell your calculator to compute the determinant of this matrix. Okay, for the TI people, this is what you want to see on your screen. Determinant of matrix A, like that. Okay, so what you got to do is you got to quit. Second quit. Press the matrix button. Okay. Press the matrix button. Go to math, and determinant should be one of the choices, right? Select determinant, and then this pops out. Now we have to get matrix A there, right? How do I do that? Well, it's actually like this, yeah? So how do you do that? You press the matrix button again, and names, select A, close the parentheses, press the enter button, and you should get -1. Did we get that? Oh, the thing did it real fast. Yeah, too bad you can't use it on the quiz and test. You gotta be the calculator. Now for the prism people, okay, I gotta look at it. Okay, you inputted it all? Okay, press the options button. No, that's not it. We gotta get out of there. Okay, press exit. Press exit. Press exit. Okay, so press exit until you get to the home screen. You guys do that? Yoshina? Saito? You know what the home screen is, right? The one where you calculate the numbers. Okay, now press options, I think. Option. And then math. Oh, there's determinant. Select determinant. And then press math. And then A. Alpha A. And then execute. Katoi! You guys got it? Saito? Okay, go to the home screen. Oh, then math. Yep. Math and then alpha A. So you guys on the prism, you cannot just put determinant of A. You have to put determinant of matrix A. So now, with the calculator, you can compute the determinant of any square matrix, 10 by 10, as long as you can punch in the numbers. 100 by 100. How long would that take you to punch in all? 100 by 100, how many numbers is that? 10,000 numbers. So punch in 10,000 numbers in. And what happens if you punch just one of them in wrong? It's going to be wrong. Okay, so this is your goal for tonight. You got to be able to compute a 4 by 4 determinant, because you're going to have plenty of these on the test. And it's all or nothing. You just make one arithmetic mistake, it's nothing. Start crying already. But there is an easier way. Like I said, like in tonight's one, look for the row or column that has the most zeros. You know what I'm talking about? So like if there's 3 zeros in one row or column, then you really only have to compute one 3 by 3 determinant, right? Okay, now the rest, not the rest of the time, but I also want to show you how to use your calculator. So we learned how to compute a determinant, right? But okay, now let's say that we already have this punched in as matrix A, huh? Okay, now what if, so this is matrix A. What if matrix B is, let's say, pick some numbers. Nah, 0 is for the weak. No, you want double digit numbers? I was thinking single digit numbers. How about 3, 2, 1, 4, 3, 2, 1, 4, 3, 2, 1, 4. Like that. Can I multiply these two matrices? This is 4 by 4. This is 4 by 3. So you can multiply them because this number is equal to that number, and the result is going to be. Okay, now tell your calculator to multiply these two matrices. Okay, so you already have A in there. So what you got to do is you got to get B, right? So TI people, press the matrix button, edit, make matrix B 4 by 3, and then input the numbers. And then for the prism people, you remember how to do it? So get matrix B, make it 4 by 3, and then punch in the numbers. Okay, now, TI people, get to the home screen, second quit, and then all you have to do is tell your calculator to do this. And it'll multiply matrix A times matrix B. So all you gotta go is press matrix, names, it's already on names already, select 1, then press the matrix button, select 2, press the equal to, the thing just spits out the answer, right? Now for the prism people, you have to get this on your screen. Mat matrix A times matrix B. That's what you have to do. So remember how to get matrix? You got to go options, and then select mat, alpha A. Now you have to put that time sign there, and then matrix B, press execute, and then you should get the 4 by 3. Everybody can do it? Oh, very good. And you know your calculator can compute the inverse. You know how long it takes to compute the inverse of a 3 by 3 on last night's homework? How long did it take you? Oh, I'm not done yet, Mr. Park. Okay, here's a 4 by 4. How do you tell your calculator to compute the inverse of this 4 by 4 right here? Well, TI people, okay, on the home screen, just tell your calculator to do that A inverse. Oh, sorry. A inverse. So you gotta go matrix 1 and then x to the negative 1. Press it. How long did it take? 1 second. Okay, now for this, you guys people, matrix A inverse for the prism people. How long did it take? So was it like almost instantaneous, or did it take a while? Oh man, this calculator good. Okay, now, yesterday, didn't I teach you, remember I told you, so, like one of the most important things you can take to college with you is this calculator, because you can solve any equations and variables with it. Okay, so suppose I have 5 equations, 5 variables. Okay, I'm just going to make this up right now. X plus Y plus, no, I'm going to run out of letters if I do that. Better start with A. A plus B plus C plus D plus E equal, okay, I'm trying to think. Gosh, I got a razor in my hand. It's a sign of weakness. Okay, so 13. Okay, A minus B plus C plus D plus E equal 7. A minus B minus C minus D minus E equal -9. A plus B minus C plus D minus 3E equals -3. I want to make the answer come out nice, that's why. And then A minus B plus 2C plus, no, minus D plus E equal 11. Okay, solve these 5 equations, 5 variables. You're going to do this by hand. No, you can use your calculator. Now, what did I tell you yesterday? We're going to call matrix A what? Were you here yesterday? 1, 1. You did last night's homework. 1, 1, 2, -1, 1, 1, 1, 1, -1, -1, -1, -1, 1, 1, -1, 1, -3, and then 1, -1, 2, -1, 1. And again, when you punch this in, you got to use negative now. Do not use the minus button. Okay, do that. Matrix A, make it 5 by 5, and input those numbers. Hey, shh, don't strike one. Just give me the plate. No, I'm serious. The hardest thing about this is punching in the numbers correctly. You punch in one number wrong, you're probably fired from your job, right? Because you've got to do this. I'm telling you, in college, lots of times you're going to have to solve 20 equations, 20 variables. Most people have to go to the computer room, but I'm teaching you this. You just take out your graphic calculator and boom. What? No. I believe TI can do 99 by 99, I think. But that's assuming you don't have any games on your calculator and stuff. It depends how much memory you have, that's why. But I think Casio has more memory than I read that in the manual. So did everybody punch that in? Okay, now make matrix B this. 13, 7, -9, -3, 11. If you were here yesterday. So make matrix B 5 by 1 and input those numbers. Anyway, this is going to be on, it's not going to be on Friday's quiz, but it's going to be on the next quiz, which is next week, Monday or Tuesday. You're going to have to do this, because you're going to do it on your homework anyway. Okay, now once you have these two matrices inputted in your calculator, how do you tell your calculator to solve it? Yeah, you just go, for TI people, you punch in A inverse times B, and the thing spits out the answer. For the Casio people, you gotta go matrix A inverse times matrix B, and boom, the thing spits out the answer. And you should get, okay, Chai, now it's time.
24601.
Anybody saw Les Mis? 24601? It means nothing to me. Come on, that's Jean Valjean's prison number. It's in the song. Who am I? 24601. Okay, did everybody get that? TI people do that. Casio people do that. Okay, did you punch in the numbers?
Oh, it's -3.
Okay, you did the right thing, okay, but see, your answers almost came out, that means you punched in something wrong. Yeah, I just want to, my guess is just like one number is wrong. Did everybody get 0 for 0? You don't even know what I'm talking about yet. No, because some people, instead of 0, you know what the computer, sometimes your calculator says something like 6.2 times 10 to the negative 11 power. That's 0, people. In case you ever see that, that is 0. You guys know why? What is 6.2 times 10 to the negative 11? 0.0000000. You got to move the decimal place 11 to the left, okay? 0.00000000062. Your calculator is only correct to 5 decimal places. So what's that number? 0. No, you have to know that, because some people, they see that and they go crazy. Go, that's 0. Can you repeat this? Now, if you do have an iPad, on your Pocket Cast, there's a thing called LinSolve. All you gotta do, well, if you can find it, you LinSolve, you just punch in these equations with a comma after each one, and the thing spits out the answer. But too bad you can't use that on a test quiz either. Do you have LinSolve? Or is that only on the premium version? It's linear algebra. Oh, see, you gotta buy the premium version if you want to do it. So the only thing you can compute on that is a determinant then. That's weak. Okay, so that's today's lesson. So tonight's homework, you gotta practice computing determinants. You have to get good at it. It's very mechanical. Okay, and I'm telling you right now, there are plenty 4x4s on the test now, as you will see. You gotta be good at computing 4x4 determinants. Yeah, but Mr. Park, what happens when there's no zeros? Well, I'm gonna teach you something. I think that's Friday's lesson. You can make zeros. But you have to know several theorems. Okay, when does this class end? What? 25, okay. Let's spend a few minutes doing, what you call? Does everybody have the AMC problems? Who doesn't have? Okay, now this is gonna count as a quiz now, like it does every year. Okay, first of all, let me tell you the format of this test. So you need to report to the lower gym 7:30 on Tuesday morning with your two number 2 pencils. No calculator is allowed. Because they're gonna start at 7:30 because this test takes 75 minutes. They don't want you to miss class. So if you come in late, too bad. You're just gonna get yelled at and then whatever. Okay, now, there are 25 problems. Okay, so this is how the test is scored. If you get a problem correct, you get 6 points. So what's the highest score you can get? 150. But in the history of the state of Hawaii, only one person ever has scored 150. And I didn't know this, he was my classmate from Castle High School. Even the smartest guy from Iolani, did Doc or any of the science teachers talk about Jonathan Higa? Or did I talk about Jonathan Higa? He was like the smartest math and science guy ever from Yale. He only scored 145. But then back then, there were 30 problems worth 5 points each. Now, come on, you have 25 problems, 6 points each. Okay? If you leave the problem blank, I forget what it is. Oh, I know what it is. You get 0.
Did Jonathan Higa take your PCH class?
No, because when I came to Iolani, my first year, he was a sophomore. He was in BC Calculus. He was the top student in BC Calculus. Anyway, so when he went to college, he went to Princeton, he majored in physics and math. And then he got his PhD in mathematics at UH. And now he works for the NSA, National Security Agency. Because they have to hire mathematicians because you know how when you send your credit card information, did you ever buy something on the internet? You guys don't know, you don't have credit card yet, but how do they keep your credit card number secure? Huh? No. They just block it by putting X's there, but how do you send, okay, let's say there's a war going on. How do you send a message so that the enemy cannot intercept it and then decode it?
You blocked your number.
No. Okay, let's say we're doing a secret mission in Afghanistan. I want to send a message from here to there. How can I send it there and make sure no one, or even if they intercepted it, they can't what do you call it?
Decode.
Encrypt it. No, encrypt it. Decrypt it. How do you make sure? You use prime numbers. But that's a whole nother lecture. Okay? I'm just going to tell you right now. Right now, the system is, and this has been going on for the past several decades, if you get two very large prime numbers and you multiply them together, and I'm talking about like at least 200 digits long, okay? You get these two prime numbers, you multiply them together, you get this huge number, right? The only way that you can break the code is by factoring that huge number back into its two prime numbers. But that's very difficult to do. You might think it's easy, right? Like here, 21. Oh, that's 3 times 7. Yeah, but that's a 2-digit number. If you have like a 300-digit number, if you had to break that down into its two prime numbers, even a computer would take 10 to the 87 years or something like that. So a computer doesn't help. So that's why it's secure right now, unless if somebody can find a way to factor a large number can factor, you'd be the richest person in the world.
So he does that? Or he makes it?
No, my guess is he's probably working on something like, because they know sooner or later somebody's going to find a way to do that. So once somebody learns to factor a large number, then our encryption system now is not going to work already. So they have to have something else. So my guess is they're probably like working on things, you know, when somebody actually discovers this, yeah. Anyway, what was I talking about?
MC.
Oh yeah, MC. Okay, so every correct one you get 6 points. So number of correct times 6. What if you leave it blank? I believe you get 1.5 points. And then if you get it wrong, you get 0 points. Before it used to be negative. So some people would actually get negative score. But then they don't want to discourage students, so they just make it 0. So the lowest you can get is 0. No, before you could get negative. Okay, now we're going to count it as a quiz, okay? So what I normally do is we're going to take your score and divide it by, what did we do last year? 5? What's 550 divided by 5? 30. Yeah, so we take your score, divide it by 5, and we're going to count it out of 20. So here's your chance to get bonus. You get 30 out of 20 if you're the smartest math student ever in the state of Hawaii. Yeah, you can get a 30 out of 20. Okay, but that's very difficult to do. Now, do you guys even know why you take this test? Did Mr. Rubash, Mr. Takis tell you why you take this test? We're trying to locate the best math students in the United States. Okay, so this is what happens. If you can score 100 or better on this test, we call this the AMC 12, right? Then you get invited to take the next test. Did any of you qualify for the next test last year? Try? Qual? Did you get more than 100?
Sure.
You didn't show up. Because if you take the AMC 10, you need 120 or better. Show up. Then you get invited to take the next test, American Invitational Math exam. Okay, so this is a 75-minute test, right? This is a 3-hour test. No, at Eli, we have maybe a dozen people taking that. If you do well on these two combined, then you get invited to take the next test, which is a USAMO, which is a 7-hour test. Given over 2 days, you will be in Dr. Noe's office taking that test.
Oh.
Like 1 year, we had 3 people take it. Some years we don't have any. Like last year, I don't think anybody did. Yeah.
How far did John Giga go?
He went all the way. We're not done yet. Okay, now if you do well on this, then they select the top, how many? 30? No, the top 30, I think. Or is it the top 25? Anyway, the top 30, I think it's 30. And they get invited to this camp, math camp. So it's like a week long, I think. And then after you go to the math camp, after that 1 week, then they select the top 5 to represent the United States at the International Mathematical Olympiad. So Jonathan Higa he not only made the top 5 in the nation in math, he also did it in physics. Top 5 in the nation we're talking about. So one junior year, I think junior year he did the math, and senior year he did the physics or something. So he got to go to, and so they have it like, I don't know, all over the world. I don't know where it is this year.
How did they do?
I don't know. United States, I don't know, lately either China, Russia, or Romania wins for some reason. We don't win. Video games, that's why. Anyway, so that's why we take this test, to identify top math students. No, but it's an honor, like, to score 100 or better to take the next 3-hour test. That's not something you guys want to do. Well, anyway, so that's why we practice. Now, the way that this test works, okay, all the easy problems are at the beginning, and then when you get to the end, like problem 25, some of you might read that, you might not even understand what to do. Okay? But that's how it is. We have to identify the top students. You've got to separate the sheets from the goals. So, to maximize your score, you got to get the ones in the beginning. Come on, we're PCH. We're the top math students in the state. Right? Like number 1, you cannot get number 1. Just go home, cook rice already. Look at that. If you cannot secure the 6 points there. Okay, let's look at 1. Okay, let's look like, okay, we'll just do 1 today. Let's do, anyway, you guys got to practice this. Let's do something like with logs or trig or something. Because once you get to the medium problems, they're tough, you know. Oh, there, logs, number 11. Let's do that. Okay, the solution for this equation. Come on, we solved equations like this when we did our log worksheet. Can be expressed in the form log base b of 7 to the 7. What is b? What is the base? Okay, the first step is you got to be able to solve this equation. Did we learn how to do this? What do you do when the variable is an exponent? You log both sides. Now, which log do you want to do? It doesn't matter because, okay, you want ln? Okay, what's ln? ln 7 to the x plus 7. And why do we do that? Because now we can put the power in the front. Natural log 8 to the x, you can put the x in the front. Once you put the x's in the front, this is algebra 1 already. How do you solve for x? Okay, so distribute. So you get x ln 7 plus 7 ln 7 equals x ln 8. Put all the x's on one side. So 7 ln 7 is equal to x ln 8 minus x ln 7. 7 ln 7 is equal to, factor out the x, you get ln 8 minus ln 7. So x is equal to 7 ln 7 over natural log 8 minus natural log 7. Okay, everybody can do that. Okay, that's what we did. Okay, but the hard part for you guys now, the answer has to be written in this form, x equal log base b of 7 to the 7th power. How do I change that into the like that? Yeah, obviously you're going to have to change the base, but what do you do? Okay, simplify the bottom. So this is 7 ln 7 over natural log 8 sevenths, right? Natural log A minus natural log B is natural log A over B, right? Okay, now what? Change base? What? Okay, now for those of you who forgot the change base formula, log base B of A is equal to log base C of A over log base C of B, right? I thought we didn't have to know that already. You're going to calculus next year, of course you better know that. Okay, so forget the 7. Oh, maybe we should put the 7 up as the power. So isn't this the same thing as log base 8 sevenths of 7 to the 7? So there, we use 8 sevenths, yeah.
Can't you just separate the first part into 7 to the x times 7 to the 7 and then divide?
Oh, that would have been faster, yeah.
That's my next.
Okay, you're right. If you did that. Yeah, but what if it's not like that? No, you guys, you heard what he said? Why not just go 7 to the x times 7 to the 7 is 8 to the x. So 7 to the 7 is 8 to the x over 7 to the x, which is 8 sevenths to the x. and then you log base 8/7 both sides, so you get log base 8/7 of 7 to the 7 equal x, and then you finish. Yeah, you can. As long as you use correct mathematics, you get it. And come on, it's multiple choice, right? You 1 out of 5 chance to get a 6. Okay, do we see any interesting one? I'm looking at number 4. Number 14 looks interesting. Do you guys even remember your geometry? No, you guys. Okay, 22. Come on, we learned how to do that. Working with absolute values. If the inside is positive, leave it alone. If the inside is negative, negate it. Okay, now probability, you guys probably gonna have a hard time with that because we're not gonna learn that for the 4th quarter. Okay, let's do 14. I mean, I'm not sure if. Okay, triangle A, B, C has integer side lengths. BD is an angle bisector like this. This angle gets bisected. AD is 3 and DC is 8. What is the smallest possible value of the perimeter? Okay, we don't know what this side is, we don't know what that side is, call it X and Y. Now, do you guys know the angle bisector theorem? Of course, math team we do, right? Better know that. What is the angle bisector theorem from geometry? When you bisect an angle of a triangle, this over this equals that over that, right? Does that sound familiar?
Yes.
X over 8 is equal to y over 3. And they have to be inches. So if you want to, here, solve for y equals 3/8x. So this is equal to 3/8x then. So what is, therefore, what is the perimeter of this triangle then? What is 1x plus 3/8x? 11/8x plus 11. This is equal to the perimeter of the triangle. So I think now you can figure out what is this. Because remember, all 3 sides got to be integers, right? I don't know if that's the best way to even do the problem. Okay, I don't know. What's the best way to do this problem? Maybe just plug in numbers. Like, what would be a good number to plug in for x? 8, right?
Yes.
Right, because you gotta be integer sides. That's right, right? So if x is 8, what does this become? 3, and this is 8. Because this is 11, and that doesn't even form a triangle, right? Remember that the sum of any 2 sides in a triangle got to be greater than a third. So then what's the next one? What if x is what? 16. So if we try x is 16, what is this? This is 6. This would be 16, and that's 11. Does that form a triangle? So what is that? 22 plus 11, 33. There you go. See, that's the kind of thinking you got to do. And you know why we count it as a quiz? Because people used to just sleep the whole time. You gotta actually give an effort on this. What? Oh, okay, so how do I count it? I told you I'm gonna divide by 5. Yes, okay. Maybe you're not understanding this, child. If x is your score on the ANC, you divide by 5. Okay, example. If you get a 90, you divide that by 5. That's 18. You get 18 out of 20. That's a pretty darn good quiz, right? It's 90%. On the other hand, last year, what was the lowest score last year? 40 something. Okay, let's just say 40. You divide that by 5, you get 8. So you got 8. That's not a great quiz. But then that's not a great score. But, I don't know if I should tell you this now, but last year I gave a minimum score. So the lowest you can get on this quiz was a 16. So even if you got an 8, that's a 16. See, but now I tell you that, then some of you might sleep. I had a student once, he tried to get a 0 on his test, just to see if he could. Because if you think about it, to get a 0 is not that easy because you got to get every single problem wrong. Think about it. It's not that easy to do. No, but if you play the game, it is. You know how? Just bubble in 2 answers for each one. There's always a way around it. But you didn't think of it. I think he ended up with like a 12 or something. I don't know. Okay, we're done. Whoa, we spent a long time talking.
So is homework still matrix 3?
Yeah, matrix 3. So that's just computing determinants.
And the quiz on Fridays on matrix 1 and 2, right?
Yeah, Friday's quiz is only on matrix 1 and 2. So it should be easy, right? I mean, what can I give you? Find the inverse. I'm not going to give you a 3 by 3. You better be able to find the inverse of a 2 by 2 using the theorem. And you got to be able to do matrix algebra. You got to be able to multiply. That's the. Going to have lots of questions where you got to multiply. Oh, we were